Hi everyone, in today's lesson we're going to talk about graphs of ellipses. Now an ellipse is a set of all points P in a plane such that the sum of the distances of P from two fixed points in the plane is constant. Now this definition is a little bit tricky, so I would like you to refer to what we discussed in class. So just to review, an ellipse has those two fixed points. So we're going to start by graphing one fixed point here, which we will label with F1, and one point here, which we will label with F2. These are what we call our focal points, okay? So these are those two fixed points, and we are going to create an ellipse around it. Now, there are two components. There are vertices and covertices. So our vertices are always in line with the focus. So we'll call this V2 and we'll call this V1. Those are for my vertices. And they also lie on our major axis. So this here is my major axis. So on the major axis, we have our focus or our foci and our two vertices. And then we have something called covertices, which we'll label up here. We'll call this covertice 1, and we'll call this one covertice 2. So because our major axis is going horizontally, we have an ellipse that looks like this. Now this ellipse here looks like an oval. That's the difference between an ellipse and a circle. So again, just to repeat, we have two fixed points. We have two vertices that lie on the major axes, and then we have our covertices with our center all in the middle. Okay? Now we're going to graph an ellipse with a vertical major axis with a center at the origin. So here's a center, and we need our two fixed points. So in order for the ellipse to open up vertically, our foci need to be on that vertical major axis. So we will call this F1 and we will call this F2. And just as before, see how our focus are on our major axes? Here, my major axis is right here through those two foci. That's my major axis. But now my vertices are right on that axis as well. So we'll call this V1 and we'll call this V2. And we need to label our covertices. So I'll label this CV1 and CV2 covertices. So this is what my ellipse would look like. Here's my covertice, covertice. Here's my center, and here are my two foci. Okay? So we say that the vertices are the endpoints of the major axis. So here's my major axis, and here are the endpoints of that major axis. Here's my major axis, and here are my endpoints. Okay, and then we say our covertices are the endpoints of something that I'd like to call our minor axis. So I will label here, I'll show you here, this is my minor axis, okay? And then this one would be my minor axis. Okay. So the covertices are the endpoints of the minor axis. Now, these vertices here and here on the major axis, we call those vertices A. So this point here is A, comma 0. So I went from the origin and I went over A, and then we're going to go back negative A. So this is negative A, comma 0. Same thing on my vertical ellipse here, that on our vertices going up here, this is 0A, and this is 0, negative A. So, what does that tell us? That tells us that the distance from the center to the end of the vertices, so from here to here, is A. And from here to here is also A. Same thing now here. From here to here is A, and from here to here is A. So we say the distance of the entire major axis is 2A. If this is A and this is A, the whole thing is 2 times A. From here to here is A, from here to here is another A, so that distance of the major axes is 2A. Now we said our co-vertices are on the minor axis, and we use the letter B for those. So the distance from the center to one of the co-vertices is B, and the center to the other co-vertice is B. So this point up here would be 0, B, and this point down here would be 0, negative B. Same thing here. The distance from the center to one of the co-vertices is negative B, 0. From here to here is B, 0. All right, so this whole distance from here to here is B, and from the center to this other point is B, so the distance of the minor axis is 2B. Okay, to find the C value, or to find the foci, you must find the C value using this formula. So this formula is C squared equals A squared minus B squared. That will help us find our coordinates of our foci. So just to reiterate here, my focus is here and here. So the distance from here to here is C, and the distance from here to here is C. So this is C, and this is C. So the foci would be C0 and negative C0. Same thing up here. Here's C and C. So this would be 0, C and 0, negative C. Okay? So, we know that an equation of an ellipse has a horizontal major axis, like this, horizontally, when our A value is greater than our B value. So when A is greater than B, or when the first number in the equation is bigger than the second. An ellipse has a vertical major axis when B is less than A, or when the B value here, the minor axis, is smaller than the major. Now, all the stuff that I just talked about is honestly definitions, and it's not as bad as it seems. So, let's talk about equations. Okay, so the easiest thing that I can say is that the A value, first we should write this down somewhere. The A value is always the square root of the larger number. And the B value is always the square root of the smaller number. Okay? So, the best thing that we can say is that if the A value, or the number in front here, is bigger than the number here, then we have a horizontal major axis. But if my B value is smaller than my A value, then we're going to have a vertical major axis. Okay? The A always corresponds with the vertices, and the B always corresponds with the co-vertice. Okay, so let's look at this first equation here. So do we see here how the first number is smaller than the second number? So the A value we know is always the square root of the larger number. So we know that the square root of 16 is going to be my A value. So we can write that here. The square root of 16 is 4. That's my A value. My B value is the 9, so it's the square root of the smaller number. So the square root of 9 is 3. Now the center for this one's very easy. The center is actually 0, 0. And the way you can tell is looking at this equation. You see how we have a center not at the origin and we have the x minus h squared and y minus k squared? That kind of looks like a circle, right? So these two equations are all equations where the center is not at the origin when these two are. So now since the first number is smaller than the second number, we have a vertical major axes. So that falls under this category, that the smaller number is bigger than the first. I'm sorry, the first number is bigger than the second. So let's look at the second graph. We know that the center is 0, 0 because it's x squared and y squared. We know the square root of the bigger number is always a, so the square root of 25 is 5. And we know the square root of the smaller number is always b, so the square root of 4 is 2. Now since the first number is bigger than the second, so we're here, a is greater than b, we know we have a horizontal major axis. Okay, let's look at the third example. Since the first number is larger than the second, we are in this category where we have a horizontal major axes. Now my center is opposite these signs, so 3, negative 7. A is the square root of the bigger number, which is 6. The square root of the smaller number, square root of 25, is 5, and that's my b value. Okay, same thing with the last one. My center is the opposite of these values, so 1, positive 4. We see that my first number is bigger than my second number, so I have a horizontal vertical axis. And the square root of the bigger number is always a, and the square root of the smaller number is always b. Okay, now let's see if we could put this all together to graph some equations. Alright, let's move on to the second page now. So, the first thing we're going to do with this problem is analyze it. The square root of the bigger number is always a, so the square root of 25 is 5, and the square root of 16 is 4. So we have our a and our b. Now, how do we tell if it's a horizontal axis or a vertical axis? It's horizontal if the first number is bigger than the second, which it is, so therefore it's horizontal. Since I have x squared and y squared, my center is at 0, 0. Okay, so before we do anything else, let's put this all on the graph. So my center is at 0, 0, and they tell us that my a value is 5 and my b value is 4. We know that the a is always with the vertices, and my b value is always with the co-vertices. So, my vertices, if my a value is 5, remember, it's 5 from the origin, so 5 from the center. So we're going to go 1, 2, 3, 4, 5, and put a dot, and negative 5, and put a dot. So those are my vertices. So we could label V1 and V2. Now my co-vertices go the other way. So my co-vertices are going to go up 4 and down 4. So here and here. So CV1 and CV2. Now I know my vertices, I know it opens horizontally, so that's why my vertices go here, not the co-vertices. So what is this ellipse going to look like? Nothing other than this. That's it. So what are the vertice ordered pairs? So we've got 5, 0, and negative 5, 0. My co-vertices are these points here, which are 0, 4, and 0, negative 4. The major axis is the distance from here to here, where my vertices lie on, which is 2 times the a value. So my a value is 5, so from here to here is 5, from here to here is 5, so the length of the major axis is 10. My minor axis is where my co-vertices are on, so if this is 4 and this is 4, my minor axis is 8. And now the last thing we need to do is find the foci. We're going to need to use the equation we spoke about, which is c squared equals a squared minus b squared. So c squared equals a squared, well 5 squared is 25. B squared, 16 is b squared, or 4 squared. So 25 minus 16, c squared is 9. So if I want to find the c, I will just take the square root, and the square root of 9 is 3. So that tells me that my focus is 3 from the center. So here and here. So this is F1 and this is F2. So these are my two foci. They are 3 from the center here and 3 from the center there. So that is an example with a horizontal major axis at the center. Okay, let's try another one. Okay, so the A is always the square root of the larger number. So the larger number is 25. The square root of 25 is 5. B is the square root of 16, which is 4. Remember, A is always on your vertices, and B is always on your co-vertices. Now, since the first number is smaller than the second, that tells us that we're having a vertical axis. And we know the center is at 0, 0. So let's go ahead and graph our center. And we know that the 5 goes with the vertices. So from the center, we're going to go up 5 and down 5. So this is V2, V1. And we know that the co-vertices are 4 from the center. So 4 this way, we'll call this co-vertice 2. And 4 this way, co-vertice 1. And this is my equation of the ellipse. So my vertices are 0, 5 and 0, negative 5. My co-vertices are negative 4, 0 and 4, 0. And the length of the major axes, here's the major, right? The major goes along with the vertices. So if I'm going to go up 5 and then down 5, that's got to be 10. Here's my minor axes where my co-vertices lie, so that's 4 and 4, which gives me 8. And to find the c value, I'm going to use the formula, c squared equals a squared minus b squared. So c is what we need to find. My a is 4, so if I, my a is 5, so if I square it, I get 25. And my b is 4, so I square it, I get 16. So c squared is equal to 9. Take the square root, and I get c is equal to 3. So I know my foci are in line with my major axes. So it's going to go 3 up, here we'll call F1, and 3 down, which we'll call F2. So those points are called 0, 3 and 0, negative 3. And that is how you graph a major axis that is vertical and an ellipse with a major vertical axis. Alright, let's see if we can do problems where the center is not at the origin. Okay, so the first one, remember the a is always the square root of the larger number. So the square root of 25 is 5. B is always the square root of the smaller number, so the square root of 9 is 3. The B is always with the co-vertices, and the A is always with the vertices. So, if the first number is bigger than the second, we have a horizontal vertical axis, and our center is opposite these values here. So, negative 1, positive 3. So now we can graph. So negative 1, positive 3 is my center. So my vertices go along, since it's horizontal, my vertices are going to go this way. So we're going to go 5 from the center, which is here. 5 from the center, both directions. So here's vertice 1, here's vertice 2. Now my co-vertices are 3. So we're going to go 3 from the center, but up and down this time. So 3 up, we'll call this covertice 1. 3 down, we'll call this covertice 2. And here's my equation of my ellipse. So my vertices are 4, 3, and negative 6, 3. My covertices are negative 1, 0, and negative 1, 6. And the length of the major axis, here's my major axis. So to go, we went over 5 and 5, so 5 times 2 is 10. The minor axis is this distance, so that's 3 and 3, which is 6. And to find the foci, we're going to do c squared equals a squared minus b squared. So a is 5, 5 squared is 25, minus 9. So c squared is equal to 16, so c is 4 if I take the square root. So that means on my major axes, I'm going to go right 4, and that would be my foci, and left 4. Okay, so those are my two focal points, which are 3, 3, and negative 5, 3. So 3, 3, and negative 5, and 3. Alright, that's my third problem. Now let's see if we could do the last one. So again, the a is always the square root of the larger number, so 5. B is always the square root of the smaller number, which is 3. And B is always with the covertice. A is always with the vertice. So, if the first number is smaller than the second, we know that it is a vertical axis with a center with opposite. So negative 3 is positive 3, and positive 2 is a negative. So now we can start graphing. Here's 3, negative 2. There's my center. So my vertices is 5. My a value is 5. And we know it's a vertical axis, so I'm going to go up 5. So 2, 3, 4, 5, and down 5. So here is my vertice 1 and vertice 2. Those are the coordinates 3, 3, and 3, negative 7. So 3, 3, and 3, negative 7. Now my covertices are the b value of 3, so I'm going to go over 3 from the center. We'll call this covertice 1, covertice 2. So those values are in fact 0, negative 2, and 6, negative 2. And this is my ellipse. And the major axes is here. This distance is 5 and 5, which makes 10. My minor axis goes this way, which is 3 and 3, which is 6. And if I want to find the foci, I take c squared, which is equal to a squared minus b squared. So the a squared is 25, the b squared is 9. And if I subtract those, I get 16. Take the square root, I'll get 4. So on my major axis, we're going to go up 4. So 1, 2, 3, 4. This will be my focal point 1. And this will be my second focal point. And those coordinates are over 3, 2. So 3, 2. And 3, negative 6. And that's it. So any questions that you might have, please jot them down and ask me tomorrow. Have a good night.